Hello everyone, welcome to the next part of derivatives. So in this class I will tell you how to solve the derivative of inverse trigonometric functions. Look at the question number 1. Find dy by dx if y is equal to sine inverse of 2x upon 1 plus x square. So without applying directly formula of derivatives, whenever we have to do the derivative of inverse trigonometric function, we will use appropriate formulas so we can make it this y value smaller. Okay, so we have one formula of sine 2 theta which is equal to 2 tan theta upon 1 plus tan square theta. So whatever is given in the bracket, that is similar to this 2 into x upon 1 plus x square. Okay, so instead of x, if we substitute the value of tan theta, then it will look like the formula of sine 2 theta. And also outside we have sine inverse. Okay, so you can think about the formulas of sine 2 theta whenever outside sine inverse is there. So let's start with the solution. So first we will write y is equal to whatever is given, sine inverse of 2x upon 1 plus x square. So this 2x upon 1 plus x square, which is look like the formula of sine theta, which is 2 tan upon 1 plus tan square. So if we substitute x is equal to, let's say, tan theta. Okay, so from here we can say theta is nothing but tan inverse of x. So if you write down y is equal to sine inverse, now inside the bracket instead of x we will put tan theta. So 2 into tan theta upon 1 plus x square means tan square theta. So sine inverse outside as it is. In this bracket 2 tan theta upon 1 plus tan square theta, which is nothing but sine 2 theta. So inside the bracket we will write sine 2 theta. So this sine inverse and sine will get cancelled. So we will get y is equal to 2 theta. Okay, so now we have the simplest form, y is equal to 2 theta. So the value of theta will substitute. Theta is nothing but tan inverse of x. So 2 into tan inverse of x. So this is the value of y. Now we will find out the derivative. Okay, so if we take the derivative with respect to x on both the side, so in the left hand side derivative of y, which is dy by dx. Also you can write down y dash if you don't want to write down dy by dx. Then this 2 constant as it is, and derivative of tan inverse of x, which is 1 upon 1 plus x square. So our final answer is 2 upon 1 plus x square. Look at the next question. Question is, find dy by dx if y is equal to tan inverse of 3x minus x square x cube upon 1 minus 3x square. Okay, so here we will apply the identity of tan 3 theta, because whatever is inside the bracket, it is similar to the formula of tan 3 theta. Outside we have tan inverse, so you can think about the formula of tan 2 theta or tan 3 theta. So the formula of tan 3 theta we have 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. And inside the bracket it will be exactly similar to this. Okay, so the first part, write down the y whatever is given. After that just substitute the value of x. So let x is equal to tan theta. Okay, and from here the value of theta, which is nothing but tan inverse of x. Now wherever x is there, we will substitute the value tan theta. So y will be look like y is equal to tan inverse bracket 3x means tan theta minus x cube means tan cube theta whole divided by 1 minus 3 x square means tan square theta. Now whatever is inside the bracket, that is the formula of tan 3 theta. So we'll put tan inverse, and this is nothing but the formula of tan 3 theta. So from here tan inverse and tan will get cancelled. So y is equal to, it will remain 3 theta, and the value of theta is nothing but tan inverse of x. So 3 into tan inverse of x, y is equal to Now we will take the derivative with respect to x on both the side. So derivative of y is dy by dx is equal to 3 as it is, multiplied by derivative of tan inverse of x, which is 1 upon 1 plus x square. So if we multiply 3 into 1, 3 upon 1 plus x square. That's our final answer. Look at the third question. So the question is, find dy by dx if y is equal to cos inverse of 1 minus x square upon 1 plus x square. So outside we have cos inverse. So we can think about the formula of cos 2 theta or cos 3 theta, okay, which is similar to this. So we have the formula of cos 2 theta, which is equal to 1 minus tan square theta upon 1 plus tan square theta. Okay, so here we have to just substitute the value of x as tan theta. So the first step, write down y is equal to given. So x is equal to, we'll substitute tan theta. So from here theta is nothing but tan inverse of x. So y is equal to cos inverse and substitute the value of x. So 1 minus x is tan theta. So x square is tan square theta upon 1 plus tan square theta. So whatever is inside, that is nothing but the formula of cos 2 theta. So cos inverse inside the bracket cos 2 theta. So we will get y is equal to, cos inverse and cos will get cancelled, y is equal to 2 theta. Then replace the value of theta, which is tan inverse of x. So y is equal to, okay, we have to take the derivative on both the side with respect to x. So derivative of y, which is dy by dx, is equal to 2 is constant, and derivative of tan inverse of x, which is 1 upon 1 plus x square. So answer will be 2 upon 1 plus x square. Look at the next question. So the question is, find dy by dx if y is equal to sine inverse of 1 minus x square upon 1 plus x square. So inside the bracket it is again same thing. Okay, in the previous question it was cos inverse was there, here it is sine inverse is there. So we'll apply the same formula. So let's write down y is equal to sine inverse of 1 minus x square upon 1 plus x square. Okay, so outside we have sine inverse, but in terms of sine 2 theta or sine 3 theta, we don't have the formula which is look like exactly similar to this. So we'll use the formula of cos theta and we'll convert in terms of sine theta. So let x is equal to tan theta as we have taken in the previous question. So from here theta is nothing but equal to tan inverse of x. So if we substitute, we will get y is equal to sine inverse inside the bracket 1 minus tan square theta divided by 1 plus tan square theta. So 1 minus tan square upon 1 plus tan square, that's the formula of cos 2 theta. So we are getting y is equal to sine inverse of inside the bracket cos 2 theta. So this sine inverse and cos we cannot cancel out. So what we'll do, we'll convert this cos in terms of sine. So it can be written as y is equal to sine inverse as it is. Now cos 2 theta, that can be written as, we can write down cos 2 theta as sine bracket pi by 2 minus 2 theta. Okay, at pi by 2 function is changing, means sine become cos, and pi by 2 minus, okay, if I draw pi by 2 is here. So pi by 2 minus means first quadrant. In the first quadrant all are positive. So sine pi by 2 minus 2 theta, the answer will be again cos 2 theta only. Okay, so cos 2 theta can be written as sine pi by 2 minus 2 theta. So now we can cancel out this sine inverse and sine. So it will remain pi by 2 minus 2 theta. That's the value of y. Now replace the value of theta. So we'll get y is equal to pi by 2 minus 2, theta is nothing but tan inverse of x. Now this is the value of y. So let's take the derivative of y with respect to x. So it will be dy by dx. In the right hand side, pi by 2. So this pi by 2 is a constant term. So derivative of constant is 0 minus 2 as it is. into derivative of tan inverse of x, which is 1 upon 1 plus x square. So the answer will be minus 2 upon 1 plus x square. Look at the next problem. So the question is find dy by dx if y is equal to cos inverse of 2x upon 1 plus x square. Okay, so this 2x upon 1 plus x square, which is similar to nothing but 2 tan theta upon 1 plus tan square theta, that we have done in the first question. But that is the formula of sin 2 theta, and here outside we have cos inverse. Okay, so we'll use this and we'll convert that sign in terms of cos. So let x is equal to tan theta. So y can be written as cos inverse bracket 2 x is nothing but tan theta divided by 1 plus tan square theta. So cos inverse as it is 2 tan upon 1 plus tan square, which is nothing but the formula for sin 2 theta. So y is equal to cos inverse sin 2 theta. So y is equal to cos inverse. Now we have to write down sin 2 theta in terms of cos. So just in the previous question how we have written, exactly similar. Sin 2 theta can be written as cos pi by 2 minus 2 theta. Okay, so now we can cancel out this cos and cos inverse. So answer will remain pi by 2 minus 2 theta. So replace the value of theta. Theta is nothing but from here. The value of theta is tan inverse of x. So y is equal to pi by 2 minus 2 into tan inverse of x. So if we take the derivative with respect to x on both the side, derivative of y, which is dy by dx, is equal to derivative of pi by 2, which is 0, minus 2 as it is, into derivative of tan inverse of x, which is 1 upon 1 plus x square. So answer is minus 2 upon 1 plus x square. Look at the next problem. Look at the next important question. We have to find out derivative of y with respect to x. Y is given sin inverse of 2x root of 1 minus x square. Okay, where x is between minus 1 by root 2 to 1 by root 2. So here outside sin inverse is there. Okay, and look, if you look at carefully inside, 2 into x into 1 minus x square inside the root. Okay, so to solve this we'll use here substitution. Let x is equal to sin theta. Why it is sin theta? Because if you put here sin theta, we will get 2 into sin theta, and this square root of 1 minus x square, which is nothing but cos square, so root will be cos theta. Okay, so we have the formula of sin 2 theta, which is 2 sin theta into cos theta. So to use this, we are using here x is equal to sin theta. Okay, because outside sin inverse is there, so we have to think about the formula of sin 2 theta or sin 3 theta. So if we take x is equal to sin theta, okay, so from here theta is nothing but sin inverse of x. Let's substitute. So y is equal to, we will get sin inverse bracket 2 x is nothing but sin theta square root of 1 minus x square means sin square theta. Okay, so sin inverse as it is, inside the bracket 2 sin theta as it is, then square root of 1 minus sin square theta. So if we apply the identity, 1 minus sin square theta can be written as cos square theta. So here inside the root cos square theta will come. So sin inverse as it is, 2 sin theta as it is, then root of cos square theta, which is nothing but cos theta. So we are getting 2 sin theta into cos theta, and that is the formula for sin 2 theta. So sin inverse and inside the bracket sin 2 theta. So we'll get y is equal to, we can cancel out sin inverse and sin because this x is between minus 1 by root 2 to 1 by root 2. So it will be in that range. So sin inverse sin get cancelled. So answer is 2 theta. That is the value of y. So if we take the derivative with respect to x on both the side, so derivative of y, which is dy by dx, okay, Yeah, before that we have to replace the value of theta, which is 2 into sine inverse of x. So 2 as it is, and derivative of sine inverse of x, which is 1 upon square root of 1 minus x square. So our final answer is 2 upon square root of 1 minus x square. Look at the next question. So the question is, y is equal to sec inverse of 1 upon 2x square minus 1, find dy by dx. Okay, so here's outside sec inverse is there. Okay, and we don't have any formula in terms of sec 2 theta. Okay, we are mostly using sin 2 theta, cos 2 theta, tan 2 theta, and so on. So you can think about sec inverse. Sec is nothing but reciprocal of cos. Okay, so inside the bracket we have 2x square minus 1. So the similar formula we have of cos 2 theta, which is 2 cos square theta minus 1. So let's put here x is equal to cos theta. Okay, so from here we can say theta is nothing but same as cos inverse of x. So if we substitute here, y is equal to sec inverse bracket 1 upon 2 x square means cos square theta minus 1. So sec inverse as it is outside bracket 1 upon 2 cos square theta minus 1, which is the formula of cos 2 theta. So we'll write here cos 2 theta. So sec inverse as it is. Now 1 upon cos means sec. So 1 upon cos 2 theta means sec 2 theta. So you can cancel out this sec inverse and sec. So y is equal to, we'll get 2 theta. So replace the value of theta. So theta is cos inverse of x. Now if we take the derivative on both the side, so derivative of y, which is dy by dx, is equal to 2 as it is, derivative of cos inverse of x, which is minus 1 upon root of 1 minus x square. Okay, so if you multiply 2 into minus 1, which is minus 2 upon square root of 1 minus x square. So that's our final answer. Now look at two most important questions from inverse trigonometry derivatives. Look at the first most important question. We have to find out dy by dx. Y is given tan inverse of square root of 1 minus cos upon 1 plus cos. Okay, so whenever you are getting this type of terms, 1 minus cos and 1 plus cos, we have two important results. 1 minus cos nx can be written as 2 sine square nx by 2. Means whatever angle is here, half of that angle will come here. And 1 plus cos means 2 cos square nx by 2. Okay, 1 minus means sine square, 1 plus means cos square. 2 is fixed. So we'll apply these formulas here. So y is equal to tan inverse as it is, square root as it is, 1 minus cos x. So here what is n? N is here 1. 1x is there. So 1 minus cos x formula will be what? 2 sine square. N is 1. So 1x by 2. That means x by 2. Divided by 1 plus cos. 1 plus cos means 2 cos square. Here also n is 1. So 1x by 2. Okay. So y is equal to tan inverse of, inside the bracket we can cancel out this 2 and 2. So what will remain inside the bracket? Sine square x by 2 upon cos square x by 2. So we know that sine upon cos, which is nothing but tan. So sine square upon cos square, that we can write down as tan inverse as it is, square root as it is. Sine square upon cos square is nothing but tan square x by 2. So y is equal to tan inverse. Now square root of tan inverse, which is nothing but tan x by 2. Root of tan square, which is tan x by 2. So tan inverse and tan we can cancel out. So y is equal to, it will remain x upon 2. Okay. Now we can do the derivative on both the side with respect to x. So derivative of y, which is dy by dx. Then derivative of x, which is 1 upon constant 2 as it is. So our answer is 1 upon 2. Look at the next important question. So the question is, find derivative of y with respect to x. Y is given tan inverse of cos x minus sin x upon cos x plus sin x. Okay. So to solve with this question, let's write down first of all y as it is. So y is equal to tan inverse bracket cos x minus sin x divided by cos x plus sin x. So remember that whenever you are getting inside the bracket cos plus sine upon cos minus sine upon cos plus sine, the first thing you can do it, divide every term by cos. Okay, divide each term inside the bracket by cos x. So if we divide each term by cos x, so what we'll get, y is equal to tan inverse of bracket, so cos x upon cos x, which is 1, minus sin x upon cos x, which is tan x, whole divided by, in the denominator also, cos x upon cos x, which is 1, plus sin x upon cos x, which is tan x. Okay, now we'll use this formula. We know that tan a minus b, that is tan a minus tan b upon 1 plus tan a tan b. Okay, so you remember this formula only, tan pi by 4 minus x, which is actually that is same as tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. Okay, but the value of tan pi by 4, which is 1, so it ultimately gives you answer 1 minus tan x upon 1 plus tan x. So whenever in the question you are getting like this, 1 plus 1 minus tan upon 1 plus tan, and that is nothing but the formula of this outside tan inverse as it is 1 minus tan upon 1 plus tan, which is the formula of tan pi by 4 minus x. Okay, so we can cancel out this tan inverse and tan now, so it will remain y is equal to pi by 4 minus x. So if we take the derivative now with respect to x on both the side, so derivative of y, which is dy by dx, is equal to derivative of pi by 4, which is 0, constant part it is, and derivative of x, which is 1. So our answer is minus 1. So this is all about derivative of inverse trigonometric function. Thank you.